In this video, I'm going to solve this question 273 integer to English words. Let me read the question first. Convert non-negative integer to its English words representation given input is guaranteed to be less than 2 to the power of 31 minus 1. Example 1 is 1, 2, 3, so output is 123. And English, the example 2 is 1, 2, 3, 4, 5, 12,345. 1,234,567. Okay, so the number is digits divided by 1,000. So we can split the number into several numbers. 1,234,506. Oh, I see 1,206,634,500. Okay. Okay, first I'd like to write the list. So I'd like to first create a dictionary. First, one, two, thousand, billion. Billion is to the power of 3 times 3. So to the power of 9 and 2 to the power of 31 is, and so 2 to the power of 10, almost the same as the 3. So 2 to the power of 3 times 3 . Oh. Okay, so the number will not exceed 10 billion. So first thing we should do is divide num into, so let's say, wait a second. I'm considering if we can convert number to string. Is that useful for solving this question? I think we don't need to do that for now. So the approach is going to iterate through the number, and then so first, so let's say so we are going to start with the current digit. And we are going to iterate through the number. While num So digit is n. Let's say number name equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We are going to use this dictionary. Digit. So we are going to iterate from right to left. So let's say word list. Okay, now let's look at example 2. It says, let's look at example 1. 123. So we are going to start with 3, and then go to left and 2, so 20. Oh, it's let's say one's name. Wait, do we need to handle 11, 12, 30? Yes. Okay. 10's name equals eleven to 12, 30. No, not 30. 13, 14, 15, 16, 17, 18, 19, 20. Okay. Ten's name is not good. Twenties name. Two. 20. 30. 40, 50, 60, 70, 80, 90, 'Okay. Let's start with the number. Start with the number where is less than 1,000. If we can solve this question where the number is less than 1,000, so we can start this as a starting point, and it is easy to improve that. It is easy to modify the function so that can handle the number which is greater than 1,000. So my idea is that if so okay, if n less than 1,000, then return okay. Now let's consider the case where n is less than 1,000. And before that, we should consider the case where n number equals 0. 0. Reverse. Now I think we should get the first two numbers, so we should do another approach. If then return of n. Now n is equal to or greater than 1, so 2D now equals divided by 100. If num in tens name, so change name of to the num. Else second digit equals to the num divided by 10. Now and the num is oh, print this name on second digit. Okay, now finally we need to handle the 100th digit. Hundred digit is n divided by 100. Say 100 and list have append one's name of digit. Okay, finally returns join reverse list rep. Okay, let's run this example. Let's run this partly implemented function with the given example. 74. Okay. One's name. So let's look at second digit. Second digit is 2d num divided by 10. Oh, I made a mistake here. Okay, 123. At least it can handle the case where case is just 1, 2, 3. Let's try another case where 90, 23. So no, 923. How about this? 19. And 0 case. Okay, now let's extend this idea. Now let's implement this block. Num is equal to or greater than 1000. So while num so let's call it temp is so press 1000. Now div mode 100 no 1000. And so we are going to append as to temp. Now let's use the example 2 and walk through the code. Now the temp is 345 and append that to answer. Now we divide num by 1000 and num is, let's say, 12. So we are going to add the thousands. So let's use dict. Say count equals 1. Dict count. Dict count. So if num and finally return okay, now let's use the example 1, 2 for testing. $12,304 45. Okay. Uh, 40. Okay, let's try this case. I'm not sure if my typing was correct. So 40, 14, okay. Now let's try this example. 1, 2, 3, 4, 5, 6, 7. Oh, yeah, right. I need to increase count. Okay, let's try example 4. Okay, let's submit the code. 30. Oh, yeah, right. This is a special case. So if number is 30, then so 2D num is intent name. Okay, 30 is intent name. We are going to append 30 to word list ref. We don't need car digit. Okay, let's walk through the code. N equals 30. 2D num is 30 divided by div mod 100. So 2D num is 30. 30 is intent name. No. So second digit is 30. When I'm searching 20's name in my code, and it turned out we didn't use it. I think we should use this in this way. And run it. And if this happened, it should return 190. Okay, let's submit the code. Oh, we use 20's name. So let's use its 10's name. Okay, let's use the example here. 1, 2, 3, 4, 5. 6, 7. 8, 9, 1. 9, 0. Okay, submit the code. 100 off. So I forgot to consider this case. think we should consider this. Wait, it should return 100. Okay, let's try this. $101. Now second digit is 0. One's name. Wait. Now, in this case, it's weird. It should return 100. 100 to 0. Okay. Yeah. And let's try this. $101. Let's try this. Let's submit it. 1000. If temp okay. Okay, in this way, if the temp is 0, we don't append 0. Okay. If the let's try it. Zero. It's not 0. Append it. I'm not sure if it handles the 10,000. Okay. Okay, let's submit it. 1 million. Oh. Okay, let's try this. 1 million. So in the first trial, temp is 0, so we don't append it. And num exists, so we're going to append 1000. We should handle the case where 1 million exists. Okay, it begins with 0. Dig up count. Okay, let's try this. So I run this here, but we are sure if we should append 1000 to the ans. So we should put a count here. And okay, let's walk through the code. So in the beginning, temp is 0. So we don't append 1000. Count is increased. Now temp is 0. Where did the one come from? try it. Okay, 1 million. One million three. 1,000. Okay, it passed all the test cases. I am tired. This question is quite tedious. I don't want to solve this on the real interview. This approach's time complexity is so let's say the length of the number, which is the size of the digits of the number, is n, then the time complexity is O of n, and the space complexity is, so we just use word list ref, and this is at most 3, so we can count it as a constant space, so the time space complexity is O of 1. Okay, that's it. Thank you for watching.